This is a description about why I built this ventilator and why I built it the way I built it. This is in the description text of this video and also the other video. Matter of fact, you can see the other video's link in the upper right corner there. This is a technical description of the ventilator I improvised. It's a fairly detailed description of what it does, how it works, and how I built it. This graph, you've seen this many times on YouTube probably, but I need to explain what the basic idea, what we're after here. What we want to do is put air into the lungs at some controlled rate. We want to manage the peak pressure very carefully because there's a lot of, you can kill people by getting too much air pressure. So we regulate this. We control the total volume of air into the lungs. In my case, we control it by managing this time interval right here. And similarly, on the exhale side, we manage the rate the air exhales. And optionally, I didn't implement this, but you could, is to maintain a positive back pressure right there. For the application I had in mind, that's gilding a lily, but for a respiration therapist, that might be something you'd want to implement. So how we do this. The source for mine is shop compressed air. This is high pressure air, say 120 or 150 psi. It's very easy to create air like that, which we then filter right here. That's the big orange filter and my other filter. What comes out of that is breathable compressed air. It's been run through filters and whatnot, so that air is certified to be a breathable air. You can breathe it for years. We use a precision pressure regulator, a 0 to 2 psi range precision pressure regulator, to manage this ultimate pressure here. Now, a note, in real life, you would want to account for a failure in that regulator by having an emergency relief valve right here. I didn't implement that, I don't show it, because for the cases I'm going to be using this, I'm going to be right there, and if that regulator blows, I'll know it and I'll be there to handle it. We have a non-contact valve around this half-inch, all of this is half-inch tubing, I should have written that. We have a non-contact valve to manage this rate, so we have a constant pressure, a variable valve that leads to a rate that we can control. Eventually the rate will peak out against the regulator and then drop. That's going into the mask. That pressure, excuse me, note that we have positive pressure at all times going into the mask, so there's no back contamination that can happen from even a forced exhale into the positive pressure side of things. We then have another of these non-contact valves on the exhale to control the rate here. So in order to trigger an exhale, we open, when this valve opens, I'll explain how that happens. That vents the outtake of the mask directly to the atmosphere. The rate of exhalation, if you want to control it, is controlled through this non-contact valve. If you don't have that non-contact valve, this will drop at whatever rate the lungs are capable of down to whatever pressure you allow. If you want to have a positive pressure, back pressure on it, like a CPAP kind of setup, you can put a back pressure regulator right here. I didn't, but you could if that suited your purposes. Then we have another filter. This one's to clean up the exhaust air so that you're not contaminating the clinical environment while this thing is operating. In order to operate these mandatory cycles, we have two standard process control timer relays chained so that they implement an on time and an off time, and on, off. So one timer you can set to T1, the other set you set to T2, the exhaust time over here. These are those two little round things you can see in my other video. I had two primary objectives when I built this. First, as a former EMT, I'm comfortable with managing the breathing of the patient, where the patient's probably one of my loved ones. So there's not any automatic features in this thing. You could add those, but that's extremely complicated to get right. So I was more comfortable with manual control. The other key feature is that if this thing fails during use, I might end up killing my loved one. So this is all built out of industrial, super high reliability components that are certified. They will run for hundreds of millions of cycles without failure. They're also in the unit I'm going to build for real life. They can all be replaced very, very quickly if a failure occurs. So if I get nervous enough to think I might lose an important component during use, I will have backups of all the parts. I also have a mode where I run the air directly out of this regulator to the mask, so I can use a manual cycle. That is to say, I stay awake and apply the mask to apply pressure and remove the mask to release pressure. That way, if there's a failure in any of these components over here, I can still keep going. I think that's my video.